man against a woman against computer 1. Thank you for your patience. So, the point I'm trying to make is that as an evolutionary biologist, to me, it's not surprising, given the outcomes of previous mass extinctions in the history of planet Earth, that large animals like sharks and rays, which are high up in the food chain, which have large ranges, in serious trouble these days. And I want to spend the remainder of this talk expanding on this. Now, again, probably to some of you, this will be old news. I'm hoping to some of you, this will be a bit of an eye-opener. And I will give some take-home message at the end of, what we can make with this information, with these concepts, as, practical conservation biologists. So, there we go. Now, this is a histogram of the number of species on the y-axis, logarithm of the number of species versus the logarithm of the weight. And this is the analysis for bony fishes, and this is the analysis for sharks. So the histogram is severely shifted to the right. And the largest fish, of course, is a shark. The smallest sharks, I believe, are these deep sea Latin sharks, which are about 25 centimeters long. In contrast, the median size for bony fish is 80 grams, and some of the smallest vertebrates ever, in length only about 7 millimeters. These are gobies and some freshwater cyprinids, are bony fishes. So, as a whole group, sharks are larger. And then again, I'm probably preaching to the choir a little bit here, that sharks have large body sizes, they're high up in the food web. There was just recently a report on an herbivorous shark, right? But it's a big exception. Normally sharks would be carnivores, apex predators even. They have large spatial ranges, they're long-lived, and they have low numbers of offspring. Now, all of these features of these animals are bad news for them, unfortunately. And let me elaborate. So, when we're talking about extinctions, that is not necessarily an unnatural thing. There's always a background level of extinction. So you would have habitat changes. Now imagine there's a very humid forest habitat, and then there would be a change in the local conditions. That turns into a savanna. A lot of the animals which would be in that habitat would not be properly adapted anymore, and if the range is small, they would go extinct. Or you could, animal species could be outcompeted. There would be one herbivore, and then a different herbivore species evolves or invades the area, and the original species which was there, which might have a jaw which is not up to the task anymore, will go extinct. And that is balanced by speciation. So you would constantly have a process where new species emerge, which typically happens when there's a geographical separation. So there's this classic example of these finches, right, in the Galapagos Islands, where these birds settled these remote islands, and then there were unique food opportunities, different seeds which they could feed on, and so they split into several species. So this is during normal times in evolution. This is what's happening. But there are times which are not normal times. So this is a famous figure from this paper by Raup and Sapkowski, and this shows the big 5 mass extinctions in the history of planet Earth. And they're actually the missing one. I will come to that later. So there's the late Ordovician, late Devonian, late Permian, late Triassic, and late Cretaceous mass extinction. Now so what you can see here on the y-axis is the number of families of marine animals, and these are million years before present. So you can see that from the early Cambrian on, evolution work, to greatly increase the number of families, a large increase in biodiversity, and then in the late Ordovician there was a big drop. And then there's another drop here, and you can see that it takes tens of millions of years for these recoveries. There's one of these mass extinctions which is well known because of a lot of popular science is dealing with it, which is this late Cretaceous here, number 5. So this is the one which wiped out the dinosaurs. And however, the most dramatic one is the late Permian mass extinction, which you can see here. So that was 250 million years ago, which is just before the dinosaurs started to diversify. Now, what I'd like to do, I would like to say a few words about the late end Permian extinction and the end Cretaceous extinction, and then see whether we can draw some conclusions from these extinctions to what's happening now. Now, this is, unfortunately, there's no way to keep that as a pet anymore. So in the Permian, there was a very diverse fauna of sometimes really large reptiles. And so this is not a dinosaur. So this animal lived 50 million years before the first dinosaur. So it's a different lineage of reptiles, but the Permian had this was an herbivore. The Permian had a very diverse land fauna of reptiles of very variable sizes, up to these basically cow-sized animals. And then what happened at the end of the Permian, that in the area which is now Siberia, there were massive volcanic eruptions. So they're called the Siberian traps, and you can still find the volcanic rocks there now in large areas in northern Asia. And this caused a massive release of CO2 in the atmosphere, which caused a massive episode of global warming, probably within something like 100,000 years. And that caused massive changes to the ecosystem of the planet, including the fact that many of the shallow oceans of the area became anaerobic. So there was no oxygen in the first 100 meters in some of the oceans in the late Permian. So basically, what we have a geological event which caused a massive restructuring of the ecosystem of the planet in a relatively short time. So 100,000 years is a very short time for geology and evolution. Now, what happened afterwards? So these pictures are from Wikipedia. They're having these great graphics here where you can always see the comparison of these extinct animals with a human. Now, after this, in the early Triassic, the planet on land was a very boring place in terms of biodiversity. So 95% of animals were what's called a Dinosaurs, which is it's a small lizard with a beak pretty much like a turtle. And then some of them were slightly larger, but there was a massive decrease in the size of the fauna, both in the ocean and on land. And it took tens of millions of years for the sizes to come back. So, very, very pronounced shift from very large animals, not quite the size of dinosaurs, but like the size of large bovines, to essentially cat-sized lizards as the largest animals in the 5 minutes. Are you giving me the time from the fiddling? I hope. Anyway, the next mass extinction is the end Cretaceous mass extinction. So we all know this happened because of a meteorite impact. The deaths were not because the dinosaurs got knocked over by the meteorite, but because the impact caused a massive darkening of the atmosphere, primary production went down, and then so again there was a massive change in the ecosystem of planet Earth in a really short time. What went extinct were these massive, massive dinosaurs. It's technically incorrect to say that all dinosaurs went extinct, because birds are really a lineage which is within the dinosaurs. So the flying dwarf dinosaurs did not go extinct. There, with very few exceptions, no land animal survived which was heavier than 25 kilos. So we have the same pattern. During and after mass extinction, the large animals go. So this is called the Lilliput effect in the literature on in evolutionary biology, like this fairy tale that this dude traveled so far in country, everybody's really small, right? The country was called Lilliput, which can be due to several factors, and most likely it's just that there is a selective survival of small taxa, and this is happening now. Why are we talking about this? We're also making a mass extinction. Next mass extinction, which is like the sixth one. They're the big five, and we are currently producing the sixth one. So what's the cause? Humans. Humans have left Africa about 70,000 years ago and migrated to all of these places. About 15,000 years ago, our ancestors developed agriculture. That led again to a massive modification of the ecosystems on planet Earth. In addition, our ancestors were very proficient hunters, and then about 200 years ago, the Industrial Revolution started, where we even started messing with the composition of the atmosphere. So again, in a span which is about 100,000 years, which is really what people were thinking is the time span for this massive and permanent extinction, we have massively changed the ecosystem of the planet. These are exactly the conditions which unfortunately affect large animals like sharks and rays first. In addition, this is Steller sea cow, which is like a giant relative of the dugong, which was hunted to extinction in the 27 years after its discovery in the North Atlantic. So, in addition to this regular Lilliput effect of previous mass extinctions, what we have us as very keen and proficient hunters. So I think we're probably seeing a Lilliput effect on steroids. To sum it up, what can we make of this as conservation biologists? I think then we are unfortunately not dealing with a situation where, unfortunately, a few fishermen in Indonesia and in the Philippines are not following the law and they're still fishing sharks, which they shouldn't. Unfortunately, I believe we are dealing with trends which have been in place in life on Earth for 400 million years, since the late Ordovician mass extinction, that we're causing a mass extinction which preferentially affects large species. And things are even getting worse because, in this current Holocene mass extinctions, we're having a super predator on the planet, which, preferentially takes out large animals. So I think, what's not the take-home message is to give up, right? And, great respect for the conservation work that everybody does here, and, this must be done and this should be done. But I think in order for us to have success, we need to be aware of what kind of beasts we are facing, and it's not like a few people breaking a fisheries law. It's we are facing a mass extinction. So I hope that was interesting and useful. Thank you.
Thank you so much, Klaus. We would like to proceed to